This MATLAB Simlink diagram models an automated driving system that that fuses camera and radar sensor inputs to perform safety risk assessments. On the left, a scenario radar block imports environment and actor data, which splits simultaneously into vision detection generator and a driving data generator radar. The camera's output passes through a bus selector to check the number of active detections, while both sensor streams feed directly into a central MATLAB function block that is labeled as FCN. This core block processes the data to calculate the time to collision and assesses simulation risk and output a driving decision. Finally, the results are routed to workspace loggers for data analysis, while real-time numeric display blocks show the current system states, including a safe TTC reading of infinity. This is an image shows a MATLAB bird's eye scope window. Visually, the simulation results of the automated driving system. The central plot tracks a blue ego vehicle moving along a lane, while transparent blue cones show the camera and radar sensor coverage areas. An orange vehicle and red tracking markers outline detected obstacles ahead along the longitudinal distance grid. The left sidebar details active parameters like ground truth, lane markings, actor properties, and active sensor detections. The top and bottom control bars manage simulation playback, which is currently paused at 0 timestamp. In continuation to this image shows the MATLAB bird's eye scope window capturing the automated driving simulation as it starts. The central bird's eye view tracks a blue ego, while the transparent overlapping cones indicate camera and radar sensor coverage. An orange block ahead marks a detected vehicle, while a red oval highlights the immediate tracking and danger zone. The left sidebar panel organizes simulation elements including ground truth data, active profiles, and active sensor types. The simulation remains paused at 0 mark, controlled by the playback options located on the top and bottom toolbars. This image shows MATLAB figure window displaying a pilot titled a plot titled TTC versus time. The line graph illustrates a steady downward trend, indicating that the time to collision decreases over time. The x-axis tracks time travels intervals ranging from 0 to 14 seconds, and while the y-axis measures the TTC value dropping from roughly 1.86 down to 0.64. And in the background, the MATLAB command window shows the exact code lines executed to generate this grid enabled graph. This visualization represents the final analysis output from the previously simulated vehicle braking or closing scenario. This image again shows a MATLAB figure window displaying a plot titled risk versus time. The line graph illustrates a step function where the risk value starts at a constant level 3 and abruptly drops to a constant level 1 around 13-second mark. The x-axis plots time ranging from -40 to 140 seconds, while the y-axis tracks the risk index from 1 to 3.5. In the background, the command window shows the sequential executed plot, title, and grid commands used to render the graph. And this image shows MATLAB figure window displaying a plot titled decision versus time. The line graph portrays a sharp step transition where the system's decision value instantly drops from 3 to 1 near 13-second marks. Then the x-axis tracks the time axis around 0 to 120 seconds. Y-axis charts describe decision states from 1 to 3. In the background, command window shows with the details of plot, title, and grid. This curve shows the behavior that maps the exact moment the automated vehicle alerts its driving action in response to changing risk levels. And these are the overall outcomes of a sensor fusion approach for real-time object detection and collision risk assessment in level 2 autonomous driving system. This is implemented as part of real-time project by students of ECE BTech second years. And I am the mentor, Dr. Parvathi, Professor of ECE Department.